So that's on there. And so if you look, it's not centered perfectly, but if you come here and look, you can see the how there's a paste blob on each side, and that's what you want.
Make sure it's recording.
Yeah, it's recording.
It's not getting a good view of it, but
Yeah, that's fine.
Okay.
But,
That's it, right?
yeah.
Okay.
And you may have to fuss around with the light so it's not reflecting in a way that causes a problem. Okay, so now let's go to C30. So what
C30.
is it? 330 nanofarad. That's a. This is kind of the pain in the butt, and if you were to organize them up front, it would be easier. 0.33 micro. Is that 330 nano?
It's
Right?
yeah, I think so.
Yeah. So we're going to go. Make a little hole. Get your components out. And I think this is the only 330. Yep. So just going to go with the tweezers, lift the plastic, peel it back just to let the one that we need out. Oh, come on. Should have made the hole a little bigger. Set it to the side. And I'll throw it on the floor. Oh, you got it. That's why you buy extras. The passives are really cheap, so always buy extras.
Yes.
So we'll go and we will place that there, kind of give it a little push down, and I'm going to center it up a bit so it looks pretty. And there we go. There's C30. Now we have 28 and 29.
C. It's
Yep,
not polarized, right?
10 mu.
Nope.
You have to be careful.
The 10 mus are going to be polarized. Well, no, these aren't. These are the
Ceramic.
the ceramic ones, but
Tantalum. Tantalum ones are going to be polarized.
right. The tantalums are for this one are just in the power supply, I believe.
Okay.
So we're going to have some tantalum capacitors here. That looks like. Try not to do that.
Okay. We got some extras, so we can use also now board. Right?
10 mu. So I think there are ceramics as well in here. 0.1. That's a resistor. That's not it. Because in the what size? That's the other thing is what size are these? These are.
419 millimeter.
Nope. We're looking for actually this code right here, 1206. 2.10 mu. I'm not certain the way I do this. 1 mu.
So the number means size?
Actually, so these, yeah, the number is a size designator. So most of what we work with are 1206s. I'm trying some that are 2 sizes down, called 0603s, because they're very difficult to do by hand, but they're not as hard to do in the oven. So yeah, we're going to use the tantalum here, and
Okay. Now you have to be careful about.
yep, the tantalum capacitors are polarized.
There is a positive negative sign, right?
Yes, and I can never remember which side the line is.
Oh, it's positive.
The line is positive.
Yeah.
You remember the other day? We looked at
I remember that.
Remember that?
the plastic. What?
It's line. There are the lines positive.
Yeah,
always.
Let me just double check that.
Yeah, the problem is, make sure it's,
So in this case, you'll have to know which side is positive and which side is negative then. But we can tell because we have grounds. These two are clearly grounds. So this is the 10 mu
Band indicates positive.
is C20.
So the band means plus.
Okay.
the line
So-
is in
Okay.
positive
Okay.
side.
Yeah.
So C26 is a 10 mu and C28 is a 10 mu. 26 there and 28 here. So we'll grab a couple of these.
last time we were.
And I should have put a designator on there to know
On the source screen, right?
on the silk screen.
Yeah.
But in this case, I can look at it and see which side is tied into the ground plane.
Exactly. That's
And-
what minus.
So that's
Right.
my minus. Yep. So we got C26. I'm just gonna tack that in there. And the first one always takes the longest because you're kind of figuring out what goes where. So and then C28 will go like that. Okay, these I think we're gonna need again. Be gentle moving it.
Which one's going on?
See how some of these have the, see the little lines coming off of them connecting to this big copper pad?
Okay. Wait, what?
Okay, so do you see how, like this side right here, see that little line coming off
Yeah.
on each side?
Mhm.
That connects it to ground, and this is a big ground plane.
Okay.
So that's how I know it's connected to ground, because it's connected to the ground plane.
Okay.
If you're not certain,
I'm gonna hold this one the last one.
yeah, look at the layout. Okay, so now we've got C29, which is 100 nano. That's 0.1 mu, right?
Yes. Yes.
So we've got C29. I'm going to start speeding up a little bit. Okay, now I've got C1 and C2. C1 is 101. So I just put away.
I think this is 06.
Oh, you're right. That's an 0603, and this is a 1206. I wasn't terribly consistent with that, and I should have been. Thank you. So we are looking for a 1 mu, and we're looking for a point. .1 mu of 603. So these you see are a lot smaller.
God.
Those. And these are still 3 sizes up from the ones that were originally spec'd on your board. Just to give you an idea. Or 2 sizes? 2 sizes up.
Wow. That means those ones were really small.
That means we
Next
can reach it.
procedure now?
Yep, we're populating right now.
Okay.
I was just showing them, these are 0603s,
Okay.
which are still 2 sizes up from the 0201s
Right,
that he
right,
spec'd. And these are very difficult to do by hand,
Right.
not as hard to do in the oven.
Mm-hmm. Yeah, they want
So we'll go and take that out.
0.3 millimeter.
Yeah. So, okay, this was what, C1?
C1.
Because, yeah, we're
100.
0.1.
100
Yep.
nanofit.
Yep, so C1, we're going to go put it right. I might have put too much solder on that.
I didn't see you put on solder on it. Your guys saw it, right?
Yeah.
Where's the solder?
Here.
You can see it when we do the other side.
Okay, sure.
Okay, now
So you
it's...
did part of solder paste, then you did that.
Yes.
No,
So it is first.
Solder paste first.
First.
Then
And glue.
solder.
And glue, because
And
this is the
glue.
back side.
Oh, that's the third one, okay. You
The-
did glue too.
Only because this is the back side.
Sure, sure. So you did solder paste,
Then
then
glue,
glue,
then
then
Now
solder.
I'm putting the components on.
Ooh, well,
no solder.
Solder.
no solder.
No solder.
Just solder paste and glue.
And then the components, then we put them in the oven, and that's what solders it.
Oh, I see.
Because the paste is actually solder. It's just in a paste form.
Oh, okay.
So this is actually has little balls of solder in it.
I see.
Okay.
Solder paste and solder together.
Oh, oops. It would help if I... Okay, see, I made a mistake here with my glue. I was rushing.
Oh, yeah.
I put the glue in the wrong place. So, we're going to have to...
Sock them up.
Hmm?
Sock back, or what do you do?
No, I'm just going to put it down in the right place. But... what I get for rushing.
Do you need a sock bag or you just
Nope,
leave
it'll be fine on there.
Okay.
It's just going to be a little dab of glue.
Sure.
So we're going to. Takes a little bit to get it through all the way through the needle.
The tube is down. No pressure.
We can if it. Oh, there we go.
There we go.
A little bit of patience. Okay, so yeah, I screwed that up. Okay, so we'll just leave that in there for now. Okay, and this was C1.
C1,
It was 100 nano.
Yep.
Okay, and then so put this back. Shoot, it came from here. No, it didn't. Where's the
Okay.
this one? And it's really tedious to keep putting these back and taking them out, but it's so hard to keep them straight if you don't. And I'm sure there's a better organization system. We just have to figure it out. Okay, so C2 is 1 mu 0603. Did I already find that one? 1 mu 0603. This one I might just punch out. There. Oops. Go back here. Okay. Now we've got, let's do C3, C4.
100 nano.
So it's the same set.
Same thing. I mean, you can pour more to the C7, C8, C11.
But they're not all necessarily on the side of the board. So I will
Oh,
go and
yeah,
I will go
yeah,
and do that, I think. But okay, so we've got, double check. This is my 1 mu.
On your C2 and C4.
So we'll go load that on C4. What else?
This is 1 mil, right?
1 mu 0603.
No, that's it.
That's it?
From here, that's 1603, 22, 23,
22, 23, and 24. Those look like they're not on the side of the board. I still don't need those. So then we've got the 0.1 mu 0603. Right? 100 nano?
C3.
Okay, and then
C7.
C7. Some of these, it's easier to just punch them. If they've got this fabric backing, or this fabricy backing on them, it's easier to just punch them through. So C7. Oops. Well, that one's gone.
Really?
It slipped out of the tweezers and shot somewhere. That's, again.
Get some extras, right?
Yeah. Okay, and then
C8.
C8. We've got on this side as well. Okay.
C11, C12.
Okay, those are on this side as well. C11, C12.
Yeah, that's it.
Okay. As you can see, once you get into a rhythm, it doesn't take all that long. Okay, now let's do C5 and 6.
So 18.
They're both 18 pico 1206, right?
Yep.
18 pico. So these are for the crystal. So now all of a sudden these look these look huge, don't they?
Oh, no, that's almost 1 millimeter.
That's height.
Oh, that's high. Okay.
But comparing them, working with them, now those are really easy to work with.
Right. Compared to the 06, 03, right?
Yep, so now we've got C's 13, 14, 15, and R1. So let's do C13 and 14.
Almost twice the size.
C13,
2.2.
they're both 2.2.
03. 06, 03.
2.2, 0603. And part of the reason, you don't need, 1206s are a lot easier to work with. This is sort of the reason I did it was sort of a trial to see how it goes. But if you've got the room, just do the bigger ones. They're easier to work with.
1206.
I mean, if I'm trying to replace
Right.
06, that would be
No, it's not. It's really not that bad. But okay, so that was C's 13 and 14
Yeah, yes.
are both 2.2. Please don't shake the table.
Okay.
When you leaned on it or leaned against it, shook. Okay, then R1.
1K, 1 watt, 0603. 1K. Oh, yeah.
So I'll just double check. Okay, 0603. Resistor capacitors, the ceramics don't have any markings. Resistors do. So you want to make sure the marking side, which is the black side with white writing, is up. So you can find out what it is if you need to. 0, 1, 6, 8, 9, 10. So we've got R1. Okay, and then the last one on here, it looks like, is C15. 10 nano. Is that the 10,000 pico? Is 10,000 pico
Yes.
10 nano? I should double check. 10,000 pico. The way that you order them, they don't necessarily match up. They don't have that designator or that size, but they have this size, so they're the same. There we go. Just put this away. We're done with the backside. So, a double-sided load. Again, some of this is experimenting.
We see that.
Takes longer to put together because you have to do everything twice.
Oh, is the backside?
Yep, which is why we have glue.
Okay.
Most board designs we're doing here are single-sided loads.
Don't shake. Okay, you're good.
Okay,
Good.
so now we're going to take this gently
Okay.
over to the oven. Turn it on. Set it here in the middle.
Okay.
Gently close it. And we're in solder mode. We've already checked that our settings are right earlier. I don't think you were here for that.
Yeah, you can repeat this part here. What temperature you want to change? Set it.
That's based on the solder paste.
Okay.
There's a profile in your solder paste.
Okay.
And so we matched that. So right now if we arrow up and down, we go to solder or repair. We don't care about repair. So if we hit set in solder, this will now take us to the different stages. And it will let us scroll through our different stages. And that's based on the documentation with that paste.
Okay.
So 140 degrees preheat for 2 minutes. 180 degrees in minute 15 in the heat stage, which is what activates your fluxes and solvents. 220 degrees for soldering for 60 seconds. A keep temperature, which helps it to crystallize without shocking, down to 215. So that will just, it won't turn on the cooling, but it will turn off the heating elements until it drops that 5 degrees. And then cool down temperature to 140.
How long?
That one, that's a cool down. There's no time. It just runs the exhaust fan.
Okay.
And even we'll let it run after that to let it cool off enough so we can handle it.
Sure.
So, essentially, we're going to let's see, we're going to exit out of that because we don't have to change anything. We're just going to hit run. And now, 12 to 14 minutes, 150 degrees, and you have a nice bundt cake.
We'll see. That's not. Do 3 lectures here. Then I think that will screw up.
Right.
So I just do it for you guys.
Right.
And this is part of, you have to kind of
Yeah. And,
adjust your settings based on how your oven responds.
I have
A better oven would respond a lot faster.
Okay.
So I might have to use a slightly longer time than I would want to make sure that the oven will get where it needs to. When those are blinking, it's telling you that the heating elements are turning on and off.
Okay.
That's how it controls the temperature.
Okay.
Just like your oven at home.
Yeah, we have so like okay. They won't like heat very fast. They just
Well, it will heat fast. It's the problem. A good one shouldn't. It should heat at a specific rate that you can program.
yeah.
This one isn't smart enough. So now we're just about done with the solder phase.
Okay.
And it's gonna, so now the heating elements are shut off. So it's just gonna wait till it slowly drops down to 215. And now it hits 215 there, it's going to cool down. You hear the fan turn on?
Yeah.
So now it's sucking cold air in and exhausting the hot. And it will claim it's done at 140, but we want to let it wait a while after that because the board is still going to be hot. And we don't want to shock it. And you want to be able to hold it. So we'll wait for a few minutes here.
So it's cool down to 140, right?
No, it'll keep cooling.
Okay.
It'll just say that it's done at 140.
Okay.
Make sure everything is done now.
But the fan is going to keep running.
Until we can touch the floor.
在上面的时候，其实上面你还是带一根绳子。
应该说
And I usually never just reach in and grab it. I always grab it with pliers or something.
对，
Just in case. Why are you filming it?
他这应该没问题。我说了，应该没问题。我已经交掉了，应该他们在出席他们家，出席他们家，然后我们那个应该是这个应该没问题，那而且到了 VP 那个对，你把那个就是那个是你的是那个出席的。因为之前我发邮件发到他们 graduate office， 他们不理我，然后找了。对，他去找他们，对，找 M。
Board's still going to be very hot. It's still hot.
Let me see.
So we'll go and we'll do an inspection then.
He's done.
yourself. And now we're going to go and inspect it to see if how everything came out.
Sure.
The glue will just turn dark red. And those look pretty good. If you guys want to take a look. And were I not, what?
The camera should go.
Were I not explaining this, that would have probably taken 15 minutes, 10, 15 minutes.
To do what?
That,
I'm gonna hold it.
To do what?
that whole
Oh, okay.
side. Which would take, and the thing is that as you,
You mean
a lot of it's the setup, a lot of it's the setup time. Once you get it all set up, you get into a rhythm, and you can start to go really fast. So the bigger the board, the more time savings. This didn't have a ton of components on it, on this side.
So always do the back side first.
Normally we won't have a backside.
Okay. Yeah, because all the components.
We'll usually be on the top. This was sort of an experiment. Try to test our capabilities.
Hold it. Hold it.
Here, for this one, is this just the glue or?
The red?
Yeah. And how's it connected both to?
That is soldered on both sides. The one side isn't great. I don't know if you want to look. This side isn't as good. You're going to have to get really close.
Oh my god, where is it?
C15. See how it works a lot better than the... Do you guys want to look or no? So you'll have to hold this to your eye, and then you'll have to adjust it. I can't. I don't know what the focal length is.
Yeah, you mean it's D2?
Oh, I meant this one right here.
Oh,
So if we look at that side...
so the glue is like kind of connects.
No, the glue's fine, but you see how the solder didn't do it got on there, but not phenomenally?
Oh, okay.
So,
Yeah.
do you want to look? Here.
I
You
gotta
have
hold
to
the
hold the
camera.
camera.
So we're looking for right here, and you actually want to see this side of it.
Oh, I can't see.
No. Bit closer.
You have to find the
Focal
focal length.
Yeah. Yeah.
So that side's done. Ta-da!
Okay.
Only 8 minutes.
That
Same thing. So we're just going to go through here, and it'd be nice if we had something to set this.
Do you need a holder for the scanner?
That works.
This board don't have that.
And there's a problem with this board, so this component's going to have to be flipped around. So it's a design error. So I'm not going to do solder on the relay because we're not using it.
okay.
So we're going to go 4 there. Let's clean this up. Just a dab on that because we don't want it to short.
It's a transistor.
Yep. One of them. Or a voltage regulator. It's a diode. We don't have, we're getting rid of the LCD, so we're not going to populate any of this LCD stuff here. Might be a little too much there. Now that just leaves the chips. This one is pretty easy.
Let's try.
No, not drag, but here, we're gonna just put a little, try and get a little tiny blob on each. It's probably overkill to do it this way.
Overkill, you mean too much? Sorry.
Possibly. So I'm trying to get tiny little blobs. And these are all going to kind of bleed together when they melt and then pull apart again.
So now it's the top side, right?
Yep.
Okay. So I didn't miss anything.
Now we're doing chips.
It's recording, right?
Now, the real pain in the ass on this is the AFE. My tip is too big to do that with. So I've been trying a couple of different methods with this. We need a little bit of solder for the thermal pad here, but too much and it'll actually squeeze out and short. So I'm kind of trying to be a little bit extra cautious. So we're going to just try something like that. Oh, screws. Actually, we'll remove a little. We can add more later if we have to. Okay. And the reason I keep cleaning it off is you can accidentally drag stuff around. So for this, I'm actually going to just put a really, I think, just try and put a thin little. I've had decent luck doing this, and then I'll touch it up by hand later. I'm not sure the best way to do this. We're still This is still kind of an experiment. And I want to keep the edges clean so I can see where they are when I put the chip in. So that's why this might even be too much. It's a pain in the ass. A stencil would make this really easy. But nope, we don't.